Okay, let's get started. So are there any questions from last lecture? Yeah. No. So the linker just, all it does is it links with the necessary libraries that, like for instance, when we want to print something, there's this little special library to help you print the screen. But the real execution is after the linker's done, it forwards it onto the CPU, and then the CPU does its thing. So the linker doesn't do the actual execution. Other questions? Okay, so let's get back into it. Okay, so this is the slide we ended on last time. And so, yeah. So we have the original source code that you're going to write. It runs through the preprocessor to gather code from any other libraries that are needed that you include, like the IO stream thing that we've seen several times. Then it brings the code into your code. You don't see it happen, but it has a modified source code at some point. Then the compiler steps in and generates the object or machine code that is more recognizable to the machine. Then the linker steps in when you say, yeah, I want to run this now. The linker steps in and grabs any other libraries and links them to your program, if necessary. And then at that point, you have an executable, which is run on your CPU. Okay, so now we understand how does the machine actually go from the original file that you're going to write to actually executing it. Well, what types of things can we put into our original program? Because that's the only thing that we really have control over. The rest of the process is already made by the compiler. So what things can we put in the actual program itself? So there are quite a few things, but the main things that we include are what are called keywords. So keywords are unique to the programming language. We'll do more detail on each of these in a second. Then we have some things that you're going to write called programmer-defined identifiers. So basically just variables that you write that are unique to your program, not to the language. So it's what you write. Then to be able to actually compute something useful, you work with operators based on the identifiers and the language itself to mix all of these operators together. So all these identifiers together. So if you want to add two numbers, for example, two variables, then that operation, the addition, is one of these operators. But there are other ones, such as like if you want to print something, the double less than symbol, that's an operator as well. Punctuation, so this depends on the language. There's a lot of punctuation in C++. So if you saw, there were several commas throughout the program and semicolons at the ends of some lines. Those are punctuation. And then, of course, syntax. So I need to be able to put certain symbols in certain places in a certain order. So if I do them in a different order, then that may or may not work according to the language. So now these work according in a general sense, but C++ has a unique set of keywords and identifiers that you're allowed to use, operators, punctuation, and syntax. So if we go back to the original program, which is this one, so we have this double thing, and then you have this num1, num2 sum thing. So what are all these things? So let's start with the beginning thing, keywords. So another term for these are called reserved words. So if you've programmed in Java before, these are also called reserved words there. Of course, they have a special meaning, and other than this meaning, they cannot be used for anything else. So they have a unique, purposeful thing in C++. So in C++, for example, every single one of them is written in lowercase. So if we look at the original program, we have these two lines. So the ones in green, the using and namespace, as well as the int, those are reserved words. They have a unique meaning in C++ and can't mean anything else. So the std and the main words, those don't have a those are not keywords in C++. They have a different meaning. So, but using has a unique purpose, namespace has a unique purpose, int has a unique purpose. But other than reserved words, we have these things called identifiers. So you make up these identifiers, these variables that you can use. So they're not part of the language itself, but they're not keywords, but you can use them and make your own as many as you want. So one use pretty much that we're going to use it for entirely is variable. So remember we had these num1, num2 things that stored these integer values. Those are variables, and another word for them is identifiers. So if we look back at the original program, the word double, that is a keyword in C++ like int was, and num1 is an identifier. Okay, so in that line, there's a keyword and an identifier in the same line. Any questions on these? And we'll go over the rules later about what types of identifiers you're allowed to use. Okay, so if we want to work with these variables and actually get something useful, we need to be able to combine them with operators. So, of course, they perform operations, and there are tons of them. I don't know the number, but it's at least 20 different operators in C++. And the cool thing is in C++, you can repurpose all of the operators, any one you want, to do any purpose you want. So if you want to define addition as multiplication, for example, you can do that in C++, which is, I guess, kind of weird, but you can pretty much do anything you want with the operators. So the types of ones that we'll commonly use are obviously the arithmetic ones. The assignment one, so this is not a quality check, this is assignment, and we'll go over what that means when we get to the next set of slides. So if we go back to the original program, we actually have quite a few identifiers. We have the equals here, and then the plus is also obviously another operator. Okay? And there are many, many other operators here, but we'll go to all of them when we get there. And of course, there's punctuation to be able to differentiate, well, when one statement ends and another one begins, for example, or when one variable identifier name ends and another one begins. But of course, there are other punctuation things too. So the ones that we saw in the original program are the commas in the first statement to say the declaration of num1, this identifier, ends here after the 5. So what do you think that equals 5 means? Yeah. Right. So I'm at the very beginning assigning 5 to num1, right at the very start. And so what do you think about num2? I don't have an equal sign for it for assignment. What do you think num2 is initialized to be? So this is part of the language. So if I declare an identifier somewhere, I probably should initialize it with something. And the one, for various reasons that most people use, is 0. And of course, sum is not initialized to anything either. But at the end of every line, and we'll go over what a line means in a bit, we put a semicolon to say, this line has ended, this statement has ended, and then the next one begins after that semicolon. And then the next line obviously has assigning 12 to the identifier num2, and then the statement ends, of course, with another semicolon. If I don't have a semicolon there, then the C++ compiler is going to complain to me and say, you did something wrong here, bad Ryan. So now you need to put we expected a semicolon here, but we didn't actually get one. Any questions on these two?
Yeah, so what is num2?
So this is an identifier that we make. So we can call it whatever we want. So I can call it Ryan Dougherty or Arkansas State. I can name them anything I want. So it's just an identifier that I'm going to use throughout the program to achieve some purpose. So if I want to add num1 and num2, so I could just add 5 and 12, but of course the values of them can change throughout the execution of the program. So I refer to them by, in some assignment somewhere, num1 plus num2. So I reference the identifier. Whatever value is an identifier, that's the value I'm going to use there. But I can call them whatever I want. Well, almost anything I want, and we'll get to the rules for that. Any other questions? Yeah.
So does a semicolon always mark the end of the line, or is like going to
It ends a statement, and we'll go over the difference between them. So obviously, like num2's on the next line, but it's in the same statement. There's a question over here, I think. Yeah.
Could you have treated num1 the same way you treated num2?
Yeah, so I could, on that second statement, say num1 equals 12. I could easily do the exact same thing. But now, of course, the execution of the program is going to change because the calculations later, well, num1 now, if I made that change, has the value of 12, and num2 has the value what? Well, it started off with 0. Did I ever change it? No. So I'm going to have 12 and 0 instead of 12 and 5. So, of course, now the execution can change. Other questions? Cool. So let's go on to that question. So what is a line in a statement? So a line is just a literal line in the file. So it has nothing to do with C++ whatsoever. It's when you're typing code and then you push enter, that's the end of the line. Okay? So carriage return just means you push enter. And of course, so if you have blank lines throughout the program, it just improves readability. If you have blank lines, it doesn't actually do anything different with regard to C++, but it makes it easier on the eyes. So if we have these 4 lines, we have one blank line in the middle. So of course, we changed the original program in some sense by moving the num2 and sum declaration up to the first line, but it still is the exact same program because the statements are the same as the original program. But what is a statement? It's an actual instruction. It's a whole instruction. So, and it can be any combination. We'll see many types of statements as we go through the class. But if you just ignore all this for a second, you can just think of a statement as anything that starts at the beginning, right after a semicolon, and goes until the next semicolon. Okay, so whatever's between 2 semicolons, that is a statement. Whether it's on one line or many lines, that is a statement. Okay, so of course this one has 2 lines, but it's one statement. So any questions on the difference between a line and a statement? Okay, so I referenced these things called variables, right? So these identifiers are also called variables. So we're going to use the terminology variables through the rest of the class because variable is much more common. So it's a named location in memory. So when I declared this variable num1 equal to something, in memory that occupies some value. So remember, in main memory we have these 0s and 1s. Somewhere. So this num1 is going to be assigned some location in memory, and then it's going to occupy some value at all times. So it either could be initialized to 0, like some of the variables we've already seen, or in the case of num1, where we initialized it originally to 5, the memory location corresponding to num1 holds the value 5. Okay? And it holds a piece of data, and obviously it can change. So if I assign, say, 12 to num2, well, num2 originally had the value, what? The default value, which was 0. So when I assign 12 to it, the program, in terms of the compiler, is going to get that assigned location to that variable. So it's just going to have some address in memory. And then when I perform the 12 assignment, the the CPU is going to say, oh, I have this 12. I'm going to store it in that memory location. So it's invisible to us. We don't write the location ourselves, but the compiler gets it for us. So it makes it really easy to say, well, I have this variable num1, and I'm just going to reference num1 whenever I need it, but the compiler's going to have some address, like address 8000, for example. Then every location where num1 is used is going to substitute the address 8000 in every place. Okay? Does that make sense? Yeah.
So if you were to accidentally assign two different values to one variable at different points in your code, what would happen?
So it depends on the order. So if you, and other things, but we're not quite ready for that yet. So if you assign it to, the first assignment is 5, and then the next one is 6 to the same variable, then it's going to assign 5, and then it's basically going to wipe out that original assignment with 6. So if we, yeah. So let's actually, an example. Actually, we can just, okay, never mind. We're not quite there yet either. So if we do if we have let's just do one example. So if we have double num1 equals 5, then I don't know what address the compiler is going to give to me. It's some address. So let's maybe say in memory, it's at address 8000. Just some address. I don't know what this actually is. So, and then let's just maybe say we do 2 assignments to this, 2 more assignments to this num1. So at address 8000, before the program even runs right here, what do you think is in that location? So before I even execute this declaration of num1, so what do you think is at address 8000? That's actually the correct answer. So it depends on the language. So what may happen is that the compiler, when you run the program, it may be running in some old data that's already still there, maybe from some other program that hasn't been zeroed out or cleaned up or whatever. But when I perform this assignment right here, and let's say it is at address 8000, well, what is the value at 8000 after that second line has been executed? When I execute this, what value is held there? 5, yeah. Because if this really is at address 8000, then I'm assigning 5 to that memory location. So the CPU is going to be working with main memory, assigning values into memory, and bringing values back in whenever it actually needs to be referenced again. So for example, if I did this instead, so if I had this line, well, if this is an assignment because this is an equal sign, I'm doing an assignment here, I got to reference the old value of num1 over here. So what is the current value of num1 before the next assignment? 5, good. So that means I'm going to bring that value out of main memory to say, oh, the original value, whatever it was, it happens to be 5. I bring it in to the CPU, I add 6 to it, and then I assign it back to the same place because I'm assigning back to num1. If I'm assigning to some other variable, it'll go to some other memory location, whatever it was assigned to. And then here, I basically assign 7 directly to that memory location. So after this next assignment, what is the value at 8000? 11, yeah, because I took in 5, I added 6 to it, which is 11, and I brought it back to the same place, so I have 11. Well, what happens after that next assignment? It basically just ignores whatever was there before and just assigns 7 directly. So what is the value now at 8000? 7, right. So all we're doing here is we're interfacing with memory in some sense. But we're thinking in a high-level idea here by saying, I have a variable. Maybe we can even call it x. We can call it pretty much anything we want. So if you want to do some calculation like x squared plus y squared, then I can just write it out in almost pure mathematical form, x times x plus y times y, if I wanted to. And then it'll look like the high-level idea to us, but in the when it actually is run, it just references those memory locations and does the calculation in the CPU. So we'll go over all over how everything works there, but do you understand the high-level idea? I got one person, so everyone's on board. Okay, so I got 2 people. Great. Yeah, 3. Great, the majority. All right, so let's go back to this. So we have to define, obviously, the variables before we use it. So if I reference, say, num1 up here, and then several lines later I say I declared the variable to be a double, whatever that is, then that's not really going to work because I'm referencing a variable that hasn't been declared yet. So C++ works in a top-down fashion. So you start at the top, you make whatever declarations you need to make, and then you use those variables later on in the program. You can't just say, oh, I'm going to have this use of this variable up here and then define it later. Some languages do allow you to do that, but in C++ it does not. So I can actually why this doesn't work. So ignore this for a second. Ignore what this program actually does. So if I move these 2 lines up here, so here, I can't see my cursor, you see that in C line, it actually tells me before I even compile that this is not going to work. You're referencing a variable that hasn't been declared yet because the declaration is on this line right here. But if I ignored all the warnings and just went ahead and compiled anyway, it'll give me an error because it says use of undeclared identifier num1. But if I move them down here, those 2 lines, then if I try to run the program, it'll work. Because the declaration of num1 is up above every single use of num1 below. Okay.
What did that file just do?
Oh, what's that?
What did that file just do?
We're going to go over that. I'm just showing an example. Okay, so this is just the basic things on variables. You got to define it before you use it. Okay, so just generally, there are 3 steps that you need to perform whenever you do any type of program. You get whatever input data that you need from the user. If there happens to be no input data, then great. You go on to the next step. Then you obviously do the processing of it. You do all the calculations that you need, and then output to the user, to a file, print to the screen, whatever. So it's just input, processing, and output. And then this next process right here is a common sequence of things that you should think about when trying to design a program. So the very first thing you should do is define what you actually need to do. Because if you don't understand what task you're trying to solve, then how are you going to even program in the first place? So if you understand what you're trying to do, then great, go ahead. Then so there are many ways to approach this, but one way to do this is to think about what are you trying to actually solve and how the computer should do it. So before you even start programming, think about, well, what types of variables do I need? And how am I going to interface them together? So if I want to add these 2 variables, well, what does that mean? I got to declare the variables first and then do the computation. So think about what you actually need to do to solve a given task. And one way that you can try to do this, although we won't do it here, is you can use some design models. So you can make a visual representation of what you need to do. Like, I got to make these lines, and these are going to connect to these lines, and I'm going to make this function. and it's going to call this other function. So you could do that if you want, but this is a step that's commonly skipped over. But if you get to more complex programming, you may want to consider this one. If you see that there's some logical error in the model that you make, then obviously there's no need to program something because there's something inherently wrong with the model. Then actually do the programming itself. Try to compile if you can. If there are any errors, like the one we saw when I moved those 2 lines to the top, then you need to actually fix them because the compiler's not going to move ahead if there are errors. Link the program. So step 8, we don't actually do ourselves. We just have the C line or whatever program do it automatically for us. Run the program itself and then correct any errors here. So why do I have 2 different parts of this where I say correct errors?
There are 2 different types of errors, runtime errors and Windows compilation errors.
Right. So the compiler may complain, oh, this is, you didn't put a semicolon here. But what if the program is syntactically correct? And at some point in the program, I divide by 0. So the program's going to obviously crash. But is that syntactically wrong if I just try to divide by 0? Well, the compiler may see that, but if it doesn't happen to see that, then that is a runtime error, as it's called. Some type of logical error that happened during the runtime of the program. So it's not in the compilation of the program, it's during the runtime. So here you would say, well, if you have some test data and you know what it should output, if there is a discrepancy between what you get as input and what you expect as output, then clearly you need to actually fix something with the logic of the program. And then here, after step 10, you go back to step 6 where you try to recompile the source code and then try again. But if you found no errors during the runtime, then you just try to validate if it works. Any questions on these steps? Cool, so this is the last slide on this, and then we'll go on to actually the cool stuff of C++. So there are 2 types of programming that we're going to kind of see both of them throughout the class. One of them is called procedural programming. So remember when I said that you need to define the variables before you actually use it? That's only true in the procedural sense. So a procedural, all that means is it's just a procedure, which means that it goes from the top down in a linear fashion. So it's not like it's jumping all over the place necessarily. It's going from the top down in a sequential order. So that's why you have to define the variables before you use it. But another side of C++ and other languages is called what is object-oriented programming. So the idea here is that you're going to make objects which hold data in some way, and then you'll try to use operators between the objects. So remember when we had the double num1 thing, and then num2, and then we tried to add them? Then, well, we can make our own object that holds maybe, that could represent maybe a student, for example. So if I want to add 2 students together, well, then we have to think about what does that actually mean? So this student object is going to hold several pieces of data, like their first name, last name, student ID, GPA, that sort of thing. So the focus here is on the objects, not necessarily procedural computation. And then you try to send messages to these objects by saying, oh, maybe for this student object, I send a message to say, oh, this student has completed this class and got an A in this class. Then what the student object on the back end is going to do is say, I need to update my GPA based off of the grade in this class that I saw. Or maybe this student has now satisfied some prereqs of some other classes. So the focus here is having this abstract thing called an object, and it interfaces with other objects and does computation on the back end. And the cool thing is that C++ is a mixture of both. So you can actually have procedural computation as well as an object-oriented idea. So you can do either one of these parts. So when I do this for research, I actually do both of these. So I make objects for some of the research things that I do, and then I do computations on the back end and link the objects together in some way. Any questions on the difference between these two? Cool. So let's do C++ stuff. So in C++, we need to understand how the language actually works. We need to understand, well, we have this int and double and main using namespace, all these different things of the language and how we can use it. We should try to understand how it actually all works. So if we go back to our original program, oh, I guess I did this in the wrong order, but so if we go back to the original program, so I'm gonna name some things of each of the parts of this program, and then we'll go into more detail about what each of these means. So this first line that starts with the 2 slashes at the beginning, that's called a comment. So what do you think a comment does? Yeah.
It allows you to put something into the code that doesn't actually execute.
Right. So I don't know about you, but when I see sample C++ program, I don't think that's part of the C++ language. It doesn't seem like the C++ authors intended you to write that. So it seems like a comment is for readability purposes. So if you have some complex code somewhere, then if you want to understand how it all works, you should probably put a comment there. And then what's the next line? It's called a preprocessor directive. So we talked about this preprocessor before, where it grabs any necessary code from somewhere else that we don't already have ourselves, and then it brings it into our program. Well, IOStream is a directive, and anything that starts with a # is something to do with the preprocessor. So in this case, # include means, okay, preprocessor, I have some directive right here called IOStream. I want you to include its source code into my program. So what do you think IOStream actually means? Right, so the IO actually represents input and output. Where do you think the output or input part of this program is? Yeah, the C out of the program. So the out represents output. So anything that is necessary to have C out work, I want IOStream to bring everything that's needed into this program. So this next line, in my opinion, is the worst line of C++ ever written. And there's a lot of misunderstanding about this line. So this is from the publisher slides, and it's actually very misleading. So it says which namespace to use. So does anyone know what this line actually does?
So you don't have to use standard.
Yeah. So this line literally does nothing. I'm not kidding. So what this line really does is allow you to not type as much. So I can actually, so if we go back to this program, whatever it does, and I took this line out, and the way I can take it out, for example, is putting it in a comment, but I can delete it also. It says, well, there's this error right here. I don't know what cout actually is, and in fact, it does not know what cout actually is, even though I include this thing called IOStream that involves things involving cout. So how can I fix this? Well, here I can say, so you don't need to know what this actually does yet. But if I do this, this does exactly the same thing. So if I put std : then cout and cin, it does exactly the same thing as if I put using namespace std. So what do you think this namespace actually means? So here's the issue with the program, the original one. What if I did some using namespace, some other namespace, and it has its own cout function, different from the std one? and I called cout something. Which one do I use? The compiler's now going to complain, are you going to use the cout from std or this other namespace, right? So the reason that this is an issue is that if you use other code from some other library and the names conflict with each other in terms of the namespace, then you may have a compilation error even though you didn't intend it to be. So by doing this, by having this std thing at the beginning, this says explicitly, I'm using the cout of the std namespace, not this other namespace. Okay, we'll talk about what namespace is later. But all this really does is it prevents you from writing std : over and over. That's the only purpose of using namespace std. It does not create any code whatsoever. Okay, so hopefully understanding of why this is a terrible line of code. But in this class, it's absolutely okay to use that because we're not going to be using any other libraries. But please, 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 if you go out to the real world and use C++, never write that line of code. But you may say, I really, 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 really don't want to type std : because it's 5 characters. That's so much code to write. So that's meant to be a joke. So what could you do instead? Well, I could say, well, I don't want to have this conflict over all of the std namespace, but I don't want to have to type std : for cout and cin, because I'm not going to use any other function from std. Then what can I do instead? Well, one way you can do it is using std cout and then using std cin. Then I don't have to type std : everywhere. So this makes it, it does exactly the same thing for this program, but it avoids the issue if you use some other function that has a conflict with some other code. Okay, but for this class, it's absolutely okay to use this, using namespace std. So hopefully we understand what that works. So in every C++ program, there's a function called main. So main says, when you try to run this program, you start at the main function, right at the top of the main function. So here, when I execute this program, the very first line of code that's going to be executed in this program is the cout line. So if I have some other functions or some other code here, those are not going to execute until main starts up. So, and we'll get to that in a second. Whenever you have a function, you always open it with a curly brace, an open curly brace. It does not have to be on a new line here, but in this case it is. And then at the very end of every function, and then some other things as well, you have a close curly brace. Okay? So every function starts with, after the parentheses of the function, whatever that is, we have this open curly brace to say the function is going to start here. And then a closed curly brace to say the function ends here. And then whatever's in between the two curly braces is the lines of the function, which in this case is the cout, and this whatever return 0 thing is at the end. Okay? And then obviously cout's an output statement. And this line's also misleading. It says send 0 back to operating system. Anyone know what that does? Yeah. Well, was returning 0, but what is it? Why is that even there? Well, I could, in fact, in C++, I can omit that return 0 line, and it'll still compile, it'll still run, it'll do exactly the same thing. So why is the return 0 there?
I'm assuming, sorry.
Go ahead.
I'm assuming it allows the operating system to know that the code is run so that it doesn't run it again.
Well, the return 0 actually stops the execution of the program because when it exits main, it's done. Yeah.
So that way the program knows that the whole function is away.
As I said, I could delete that return 0 line and it'll do the exact same thing. So why is that return 0 there? It actually has to do if some other program runs this one. So what happens is the CPU is always, the operating system's always running programs over and over and over. And the way that the program communicates back to the operating system whether this program runs successfully or that there was an error is this return statement at the end of main. So return 0, and we'll get to this. Return 0 means this program ran successfully, everything was fine, nothing bad happened. But if I return some other value, and there's a way to check what type of value is a bad value. If you return, say, 1 or some other value, that may say, oh, something went wrong in this program, and I'm communicating back to the operating system, this error occurred on this program. So, for instance, if the power supply program in your computer says, oh, there's something wrong with the power supply here, the CPU may say, oh, I probably should turn the computer off because I don't want anything catastrophic to happen. So it's a way for the program, because this program, after it leaves main, after it finishes executing main, it's not going to do anything else. So it has to communicate back to the operating system that ran it in some way. So this return statement helps with doing that. Okay, and then of course that last bit is for the closing curly brace of main. Any questions on what each of these lines at a high level means?
So
Yeah.
just to reiterate, return 0 is sending is telling other programs that was going to use this previous file to stop using it?
No, it says that this program ran successfully. There was no errors of any kind with this program. Yeah. So if like the power supply example, so if like the operating system gets back, oh, there was an error with the power supply program, then you may want to, so the technical term is halt and catch fire. So in that sense, you may want to execute instructions to turn off the computer, because like you may have something wrong with the battery, or the circuit is wrong or something. So it helps communicate, because the program is not going to execute anymore. It's done. But it has to communicate back in some way. Other questions? Okay. So, of course, there are some special characters. And this is kind of a rehash of what we just saw. So the double slash at the beginning is for a comment. The pound sign is something to do with a preprocessor. So this next one is actually an example of why C++ is so versatile. So the open-close brackets for IOStream, that has a purpose of saying IOStream is one of these directives you need to actually include. But of course, less than and greater than are also used in comparisons when we get to comparisons. So if I want to compare one variable against another and say, is this one less than the other? Then these brackets, the less than greater than symbols, also have a purpose there too. Open close parentheses is, in this program, the original one here, is to denote any parameters that are passed to the function. So for main's purpose, in this case, there are no parameters passed to the function main. We'll go into all those details about what that means. But you always use an open close parentheses whenever you write a function, even if there's nothing passed to it. Open close curly braces are when the function starts and when it ends. The double quotes correspond to something you want to output to the screen. We'll get to all that too. And then obviously the semicolon ends a line. Ends a statement. All right, so some other things before we get into all the details. So C++ is case sensitive. So I have to write the main function as lowercase m, lowercase a, lowercase I, lowercase n. I can't have some other combination. In some other languages, you can have it be case sensitive, case insensitive, but in this case, it is case sensitive. Of course, every open curly brace must have a closing curly brace, and I can actually do that in action too. So if I delete this closing curly brace and try to compile it, then it says, well, I expected a closed curly brace here. And there's no, a really cool thing about C++ too is that the errors are also chained together. So this error right at the beginning is chained to this one. I expected this closed curly brace to match this open one at the very beginning, which is kind of nice to see. Okay, so let's go back to this program. So we haven't introduced all the concepts yet, but what do you think the program does right here? So it declares a variable called num1, whatever this double thing is, and then it obviously outputs something. Please enter an integer. What do you think this line does? Right, so the cout, it kind of indicates to us, oh, we're going to output something. For cin, it seems like we're going to want to input something. So if I compile this program and run, it's obvious, it printed, please enter an integer, and it's waiting for input. So I better enter some number, let's say 5, and then so here you can actually see the return 0 at the end here. But this is all that the program does. Oh, wait a second. It says this to do, print out the square of num1. So how can I compute the square of this variable num1? Not square root. I want the square of the number. Right, num1 times num1. So I can actually do this. So I can say cout num1 times num1, and then and that's it. So if I try to run this, let's see what happens. So if I enter 5, what do you expect to be printed at the end? 25. And then that's actually what is outputted. So here we can actually get input with cin. So, of course, can I put this line double num1 down? Can I put that down here? No, why not? Right, it's after cin num1. That's before the declaration of num1, so that's not allowed. Well, what if I wanted to save this number right here, whatever the square is, to a variable? So how can I do that? Assign it to a different variable, right? So yeah, so I need to declare that other variable. Well, I could declare it right here because this is the first time that I'm going to use it. So maybe I can say, well, it was double before, maybe it's double here as well. So let's call it num2, and let's assign it to be num1 times num1. Then what should I output instead? Num2. So if we try to run again, let's try 6 to make it interesting, and then it prints 36. Pretty cool. So we can actually interface with the computer via input and output. What if I wanted to print the square is, and then after that little bit right there, then print the actual square? Yeah. Yeah, so the square is, but can I leave it like this? The concatenation doesn't work like that here, but in Java it will. But what do you think should go between these two? Yeah, the less than signs again. So That seems like the right idea. So if we try to run this program and try to enter 6, and it says the square is 36, oh, but there's no space in between. What should I do? Put a space there. So that solves that problem. What if I wanted to do this and put the turn num2 in between the double quotes? What do you think will be printed? Yeah, so it'll literally print num2, and we can actually see that happen. So if we print 6, and then it literally prints num2. So we'll go into all that next time. So I'll see you on Friday.